All right. Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced Stream. I'm Richard at Richard on the MakeCode Forum.
I am Ben at Donuts on the MakeCode Forum.
I'm Joey at JWonder on the MakeCode Forum.
I'm Sarah at Sarah on the MakeCode Forum.
And
I'm just so used to there being three people is the thing. Ben, this isn't Sarah's fault. This is Ben's fault for being here at the beginning of stream. I'm sorry.
I don't want to be here anyway.
We expect you to be fashionably late, Ben.
And I'm Thomas at Sparks on the MakeCode Forum.
First time's a charm. We got it.
All right. Thank you, everybody, for tuning in. Hopefully our audio isn't weird today because it's weird to me. And if you see me like randomly tripping over my words, it's because I have everything that I'm saying coming in through my headphones on a delay. So it's it's really, really messing with me. But
is it also with us or just you?
No. I mean, yeah, I can hear you guys too, but I also hear myself, which I don't normally do, because I'm normally, anyway, whatever. StreamYard is being weird today. All right. So today we are continuing to work on what we did last Friday, which is we're going to be doing a video game studio logo, as if we had a video game studio, which I feel like Thomas made me a little bit afraid. I have to clarify. We do not. This is not a real video game studio. All right. This is just for fun. So no one get us in trouble. Anyway, we narrowed it down to a few different options for what the name of our studio would be. And I nailed down everybody earlier today about what the choices are. And the votes were 2 votes for Scheme Team, which was me and Joey, and 3 votes for MKCD, being our studio name, which was Ben, Sarah, and Thomas. So we're overruled. Democracy. It's MKCD.
It was a coup.
And
how would you do Scheme Team? There's just a lot. That's a lot of words. That's a lot of letters. Not a lot of real estate.
I mean, a lot of video game companies have more words than that.
No, that can't be true.
Okay, I don't know if you're joking or
I'm 100% joking.
Okay.
MKCD is simple and layered, and I really appreciate that about it.
Layered,
okay.
Yeah. Mm-hmm.
It's just boring, in my opinion. But whatever, you guys already won. We're not going to litigate this. So we need to kind of nail down. I should have made you guys prepare for this beforehand. We need to get some pitches going about what we want our intro thing to be. And we don't need to decide on a final thing today. I think it's also fine if we do like a few different versions and then kind of decide which one we like the most. But let's see if we can come up with something that is like to start with, at least. And I'll give you what my idea was, which was this was more intended for Scheme Team than it was for MKCD. It might not work as well with MKCD. But an idea I had was we start on a blank screen and then we have like a brush stroke like go by and it paints a color on the screen but leaves the letters MKCD behind, and then when it's finished it kind of like fades and we do a musical jingle thingy like I don't know.
I like jingle. That's the important part. I don't care about anything else. I just care about jingle.
Ideally we would have the brushstroke make the sound of the brushstroke in Super Mario Sunshine in the intro cutscene where it goes like
that's a nice right there.
I can't do a Bowser Jr. laugh.
Yeah. Monkey sounds too?
No monkey sounds.
Oh.
All right, so I lost Joey.
But I do like the idea.
All right.
Yeah, it's not bad, certainly.
Let's come up with some other ideas, though. So one thing that I will mention is there are a few game studios that have 4-letter names that we could look into for inspiration. I mean, obviously one of those is Sega, but we're not going to do the Sega thing because come on.
MKCD doesn't quite roll off the tongue like Sega does.
MakeCode.
Oh, I guess that could work. Well, you said it, now I want to do it.
No, we're not going to do that. We could though. But the one that I'm thinking of is the Cuphead Studio, which is I think MDHR. Is that their name? Yeah, MDHR. And their logo intro is if you look at their logo, which here, let me pull it up. This guy. So basically, their intro thing is all of the letters come in from a different direction, and they just kind of like collide together into that thing, and then studio appears, right? So it's like the M comes down from the top, D comes from the right, R comes from the bottom, H comes from the left, and then they all kind of come together. And it's playing like a jazz style sting where it's like, or like something you would see in an old cartoon. Obviously, it's MDHR. Where it's like crescendoing until they hit, and then that's their thing. It's like really short and sweet. It's nice though.
Mm-hmm.
And I was thinking about some MKCD specific ones, but they all kind of revolved around us doing a similar square thing with the 4 letters.
Square thing's pretty common.
It's true.
I feel like it's too common. Like we gotta do something different.
Hey, I'm not the one who genericked up our studio name, Sarah.
Yeah, what if we did a triangle? That's way different.
All right, unpack that, Joey. We got 4 points.
Well, it's M and then KCD at the bottom. That's about it.
Yeah, I'll second that thumbs down.
It would be nice to evoke the feeling of live stream, right? Because when we're sharing a screen, we have our images on the left side. I mentioned this the first time we talked about MKCD, where like the letters can pop up on the left side, and we do have like an empty space towards the right a little bit, but that space could be filled up with like a presents. So like I can imagine like it's like beep beep boop boop for the 4 letters, and then a final like sound effect for when presents pops up.
Or I don't like this
change.
idea, but I'm going to say it anyway, and I know you guys are going to like it. We could do the MKCD and then have a little fake block thing that's like a block get dragged in that says presents.
Oh, that's really cool.
Again, I don't like this idea, but I have a feeling you guys will.
It's not bad. I think you could have a little Flappy Bird, or what is it called? Flappy Duck in MakeCode. Every time they flap, though, a letter appears. So it's like MKCD.
Oh, that's cool.
Yeah. Okay. And then it can perch on the block.
But Richard doesn't want characters.
I can be overruled, Sarah.
I will say so far the paint idea is still my favorite one. But
yeah,
I like that a lot.
Okay, I had another idea, which is all right. So imagine we have our 4 things, and imagine each letter like fades in and like tilts, like rotates up. So they're kind of like going like foop 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 foop, like fading in and rotating at the same time. Do you kind of get what I'm saying? I feel like that would be a really satisfying like animation. Especially in a square. So if we had them in a square, it would be like M, K, C, D. And then we could even, once they're all there, just like the last one could move the whole thing, like it's hitting it and then bouncing back,
That would be very satisfying. Or if they all, maybe this is what you meant, they all like over rotate a little bit and then the last one comes in from the other angle and it's like, bah.
I think the first 3 would not over rotate, and then the 4th one would over rotate, and then they would all rotate with it and then go back.
Okay. That works too.
Yeah.
Could also do like a Pikmin style thing. I don't know how to do it, but where they all like scurry in and form the letters MKCD.
True, I was thinking about that as well. So having like all of the pixels scurry in or something like that. I feel like I was thinking about like the actual execution of that, and like we can definitely code that. That's no problem. But the thing that I was thinking is like I don't think it'll look as good as the Pikmin one, because the Pikmin one I feel like works because you can tell it's little guys holding up cards, and I think it's possible that we could get that to work. Or they're not actually holding up cards. It's like the flower, but in our case, because it's pixels, they would be holding up like cards. I think it's possible we could make that work, but I feel like it's non-trivial. We would have to think about how to make sure that reads,
Yeah, it'd be tricky.
Hi, Pimmink. So, yeah. All right. So, should we start with one of these, or let's
one too.
All right. So, are we all? Let's just talk about how we're going to arrange the letters. Is everyone okay with the square thing?
Sure.
Sarah's not.
I think
It's
Sarah
just
wants an
well, are we? No, I don't. I'm not oval. I just think vertical or like I don't know, even horizontal, just like in a straight line. Like it's just.
All right. I'm gonna send everyone on a side quest right now.
Or
which
even
is-
on a diagonal line where
Sarah,
you like.
I'm sending you on a side quest. You
Okay.
This does not need to be final art. Okay. I just want to
Okay.
see a concept. Like, what kind of font are you thinking? How are the letters arranged? All of that stuff. And then I can off stream try to realize that into a finalized thing based off of whatever concept we like the most. Okay. So I want everyone, all of my cohorts here, to come up with something. And you don't even necessarily need to draw it, as long as you have a very clear description of what you're thinking. And like also valid would be like, how the Sega logo in some places is made up of lines that are parallel, that kind of twist or something like that. Like if you could describe it doesn't need to be a font like Garamond, like whatever art style you're thinking for the letters, like would be good. Because I think that a lot of times the logo itself informs what you end up doing for the animation quite a bit. So it would be a good idea for, I think, to nail down what we want this MKCD thing to look like. All right. So we're going to start doing some coding stuff, but I want all of you guys to be working on that. Woof Woof says you could do something with pixels falling from different directions. Yeah. So as I mentioned, I think last stream, like one person on our team, Mihao, actually made a demo of that at some point where we had the MakeCode logo and it like all the pixels kind of rushed in. Joey seems to think it was inside the PXD badge repo, but I don't remember how that code works. So
I checked and it wasn't.
It's somewhere. I don't know. I don't remember what he did it for, but it was for something.
It wasn't just the disintegrate effect, was it?
No. It was like they were coming in, definitely.
Yeah, that's true.
And it looks better than the disintegrate effect looks.
That's also true.
Anyway. All right. So this is all good. We're gonna do some sound stuff today. Because we haven't figured out what our finalized logo is going to look like. By the way, also, when you're doing these logo concepts, feel free to also draw them on paper or whatever. Like, whatever works for you. It does not need to be in pixel art.
I shouldn't be drawing it in MS Paint?
You can do it in MS Paint if you want.
Next level, like an iPad over here with a pen.
Yeah, you're going to have to turn off your blur if you are going to hold it up to the camera, though, so just be aware of that. Nope.
We'll figure it out.
All right. Anyway, okay. So let's switch back over to the coding screen. All right. So we want to have some sort of like little sound jingle thing that plays. Let's make sure we can actually hear this. Okay, it's very quiet. Let me mess with the mixer thingy. If I can, I always forget. Here it is. There we go.
Okay, that's better. I was gonna say it's pretty loud.
It's pretty loud.
No, it's fine.
I don't think it's actually. I mean, I'm listening to the same audio feed you guys are, so it doesn't seem that loud to me.
That's wild.
It is my speakers.
You know, my ears are pretty bad, so you can just
I can put it back.
No,
down
it was fine. It ended up being fine.
Pimming says it's good that the live stream is going to be 1 to 2 hours earlier, right? Because of the poll. So as I mentioned like 5 times in that post, we might not move the time. But also I think the consensus was later, not earlier. I'm very sorry.
Earlier would typically put it into more school area time.
Yeah, Pimming is in a very different time zone than we are.
Yes, yeah. I mean, technically it's an hour or two earlier, but you just have to consider that we might be shifting the day by 24 hours as well.
All right. We want to do some... Pimming Official says, no, I checked. Did it change? I'm pretty sure it was 1 to 2 hours later. But I could be wrong. All right. So we want to do some audio stuff today, and for that, we are going to be doing it in code. We are not going to be using the sound effect editor or whatever. We're going to like actually do some bare metal things so that we can have some really cool audio effects going on. So to do this, we're going to first go into the mixer library, and we're going to go into I think it's music.ts. There's something I need to steal here.
They're not gaslighting you. It looks like some votes rolled in 1 to 2 hours earlier is 11 to 12. 41%.
How many people have voted in that now?
39 total.
Wow.
It's 3% higher than 1 to 2 hours later.
Okay, I'll look into that.
It's weird that they're all the ones who voted for it are Pemmin Official 1, Pemmin Official 2, I'm just...
I'll do the IP address lookup and see where they're coming from. Okay. So I'm looking for... There's a function in here that I always end up copying. Not that. I want the... Oh, gosh, where is this? I thought it was just in music.ts. Do you know what I'm looking for, Joey?
I don't. I was distracted.
It's like the thing that adds notes to the buffer.
Oh, I don't know, man. Like I reviewed all this code, but it's yours.
I think the code that I'm specifically referencing is Meow's code.
That's true. That's possible.
But, well, it's in here somewhere. We're just gonna keep looking until we find it. No, it's probably in melody.ts. I forgot that like everything is in melody.ts.
Mm-hmm.
Yeah, here it is. This is what I wanted. Oh, we exported this, so I don't actually need to copy it. That's great.
Oh, nice.
Okay, so let's talk about how sound works in Arcade. And I'm actually going to open up the docs for this. So if you didn't know about this, there is arcade.makecode.com/developer, which has some kind of like advanced stuff for doing things in Arcade. And one of the things you can find in here is this music and art section. And this has documentation on the actual format for our instructions. So we have a bunch of waveforms in particular, which is the main thing I want to reference here. So these are all the different waveforms that we have that are supported in Arcade. Sorry, I'm distracted because my cat Breakfast is trying to break into a bunch of cabinets right now. He's all amped up. He's a little mischief maker. And so we're gonna be using this effectively. But the main thing that to know is basically all of the instructions that we build up in this buffer are used to control the synthesizer that we have for making sounds. And each instruction consists of a beginning frequency, an end frequency, a beginning volume, and end volume, a waveform, and an amount of time. So the idea for any of our sounds is we are going to string together these instructions. You can kind of think of it as its own little programming language type thing, such that we end up like creating a sound at the end of it. So let's play around with this. We're going to go over to main.ts. I'm going to go ahead and do... oh, wait. Actually, there's one other thing I want to look at real quick, which is I don't remember what the size of this buffer should be. I think it's 12 times however many steps you have, but... yeah, 12. There we go. All right. So let's go ahead and do buff equals control.create buffer. And we're going to just do one instruction for now for 12. Now we're going to go ahead and do music.add note. We're going to put this into our buffer. We're going to be pointing it at 0, which is the first index. And we're going to be putting in for milliseconds. Let's do a full second so we can really hear what we're doing here. Now this is the beginning volume. So we're going to put that to the max value, which is 1024. This is going to be our end volume. So we're going to put that at 0. This is our sound wave. So let's look at our table. Sarah, please choose a waveform here that you would like to hear.
Oh, triangle.
All right, triangle.
Not because it's the first one, just because
You say that, but I mean, you chose the first one.
We know the
I
real reason.
panicked. I panicked. Okay, I panicked.
We know the real reason. Sarah's truly regretting the thumbs down she gave Matt.
It's coming back up.
All right, we're gonna take this beginning frequency and make it 500 hertz, which is, I don't know, something. And this is the overall volume of the sound. This actually just scales the other two volume things we put in. It's meant to be like you put in like music.volume here. So that's what we're going to do. We're just going to pass in music.volume. And then for our end hertz, we are going to put in, we'll just leave it the same. So we'll do 500. All right. So this has filled our buffer with one instruction, which is making a sound that is 1 second long. It's going from full volume to silence over that second. It is using the triangle waveform, which is 1. And then it's doing a frequency that starts at 500 hertz and ends at 500 hertz. And then this music.volume is just making it so that the system volume affects the thing. All right, so let's actually play this sound. We're going to go do music. Oh, is this? Oh, yeah, play instructions. There we go. And we're going to pass in. So this first argument is when we want it to play. This is in milliseconds. So we're just going to put 0. We want it to play immediately. And then the instructions are going to be our buffer. And now if I press play. There we go. All right. So that's a 500 hertz triangle wave.
I was just going to say that. Like alerts in like an elevator or like...
Your plane is boarding.
Here. Let's put this inside of an on A button pressed. So a triangle wave is pretty close to a sine wave. A sine wave is just a pure frequency. Let's actually try. Let's hear that out real quick. So that's 3. So change this 1 to be 3. So a lot of people say they sound like a bell or something because bells do produce a really like clean single frequency, but they also just sound like a tuning fork because that's basically what a tuning fork is made to do. Is just to produce a single frequency, which is, you know, whatever frequency it's supposed to produce. So sine waves are really boring. Let's switch back to our triangle. That's nice. And let's just go through these and hear all the different options. So I'm going to do this, and we can just try them all out. So let's do sawtooth. So sawtooth is very buzzy. Yeah. Getting some weird phase cancellation things when you play multiple ones at one time. I think that's just an artifact of our sound system.
My left ear hears that sound differently than my right. Kind of freaking me out right now.
Okay, we already heard sine. Let's switch to tunable noise. So this is really good for making like percussive sounds or doing like you know, crashes and stuff like that. All right, next one is pure noise. So this one is used pretty much just for percussion.
I like that one. That's like you're splashing in water on a Sega Genesis.
Yeah, frequency has no effect on noise, as you might guess, because this is just pure white noise, you know, which means it has every frequency just a random amount. So frequency doesn't actually affect it. All right. Next, we're going to get into the square waves. So let me do a brief kind of explanation on square waves. All right, so you'll notice these all say like 10%, 20%, 30%, 40%, 50%. That's because if we're looking at a square wave, this is 0, and I'm going to graph a square wave for you guys. So a square wave looks like this. Whoops. Right? So it's equally above and below, and it has these evenly paced intervals. So what these percentages are referring to is what's often referred to as the duty of the square wave. So what we're looking at right now is 50% duty. It spins 50% high and 50% low. So as we go to like, let's look at 10% duty would be something more like this. All right. So it's now 10% high and 90% low. Does that make sense? And so I always think that the 50% square waves sound really computery, and they also sound very retro gamey because, as you might guess, square waves are easy for digital things to make because digital things are always thinking in terms of zeros and ones. So as they go high and low, it's very easy to kind of simulate that with processor. But let's go ahead and listen to the different square options. So we're going to start with the 50% and work down. So let's do 15. So you can hear it. That sounds very digital to my ears, you know? And then we can do just a little bit less. So you can hear it gets buzzier. It's kind of like thinner as you go down also. You'll also hear the square 10% referred to as like a pulse or spike waveform, just because it is such a short period of being high. All right, so those are those. Let's look at the last three. So the last three are all different versions of the tunable noise. So let's go with 16 first. So I feel like that one's got a little bit more low end than the one we heard before. All right, so those are all of our waveforms. And the reason I wanted to play all those is because we want to do like a little arpeggiated thing, right? And I'm wondering if you guys have any feelings of like which of those waveforms really spoke to you as being like a fun sound.
Before we do, I was just wondering, what are 6 through 10 reserved for in this?
Nothing.
Table? Just in case we decide to add more later or something.
Yeah, I think we just wanted square wave to be 10 plus a number or something. I don't remember. There was a reason we made square start at 11 and then go up to 15, but I don't remember what it was. And these three were added after the fact. So there's no particular reason that it's saved. Wolfwiff says, does the order you put the sounds into the buffer matter, or does it load the whole buffer? And I guess it would sort the buffer by the time played before playing. Is that way there's a noticeable gap if you play one song block right after another because it has to load and stuff? No. So I think there's a little bit of a misunderstanding of how this works. Let's actually... Pimming says, side note, this might be the last live stream in which I'm able to be here while it's live. So bye, maybe. Oh, that's very sad to see you go, Pimming. Please feel free to drop by whenever you can.
Mm-hmm.
All right. So let's demonstrate how these instructions work. So I'm going to change this from being a one note thing to being two notes. So we're going to make this be 24. And we're going to add another thing after this first one. And we'll make this one be the same thing, but at a higher frequency. Wait a second. I forgot to pass in the index. And let's change this back to triangle waveform. Okay. So now we should have two notes play one after another. So the sounds in a buffer are executed one after another. All right. And when you do a song, it's not actually calling this cue play instructions all at once. It actually has a sequencer that schedules each sound kind of as it goes. I won't get into the specifics because it's not really going to matter for today. But the reason that this instruction thing is really nice is because right now we're playing two sounds that are just each one instruction long. But we can actually make our sound be made up of multiple instructions, right? So let's mess around with this a bit. We're going to change it so that our end volume is not 0. We're going to have it continue to be 24. And we're going to change the length of this to be 500. Or actually, let's make it be like 200. And then we'll make this one be 200 as well. So now the first one does not go to 0 and then play the next one. It just kind of goes like, but-up, 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 which is kind of fun. So the idea is that you can, and we can make this smooth also. So let's say I wanted to go up and then down. So this is at 800 hertz, right? So I'm going to start at 500 and we're going to make this go up to 800. So there you go. We're starting
Nice
at 500
little, like,
hertz.
submarine
We're going
alarm.
up to 800. We're staying at 800, and then the volume's going to 0, is what the sound now is. Which is fun. So that's how you can end up making different instruments. Different instruments are basically just different combinations of the frequency changing over time, which is cool. So I personally am a big fan of square waves for old video game reasons. Like the NES, like I feel like the NES is all square waves. I think it did have the ability to pronounce, like to do some other waveforms, but I think most of the music you hear on there is square waves. And I feel like the classic thing you get with a lot of old school music is you kind of have it going in between two frequencies, like just going up, down, 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 as it like fades out. So let's make a function that'll actually do that. So let's make a function. It's gonna be like make sound, and this is gonna take in a frequency. We'll make this be high. We'll make another one be low. We'll make duration, and we'll make steps. Right? So what we're going to do is we are going to take our steps thing and first use that to create a buffer. So we want our steps to be multiplied by 12. So we're going to do steps times 12 because each instruction is 12 bytes long. And what we're going to do now is we are going to make a number of entries in here that's equal to steps. So we'll do let I equal 0. I is less than steps, I plus plus. And in each of these, we're going to go ahead and do music add note buff like this. Wolflip says, wait, so what does the second number in the thing do? The 0 and the 12? I have a lot of questions, LOL. What was that developer site you mentioned? Yeah, so the developer site is arcade.makecode.com/developer. Right there. Oh, it got pasted everywhere. It's interesting. So yeah, there it is up on stream. And the second note is the index in the buffer to write the instruction. So because each instruction is 12 bytes long, it's going to be equal to the index times 12. So we write the first instruction at 0, we write the second instruction at 12, the third instruction will be at 24, the fourth would be at 36, so on and so forth. So right now, let's do exactly that. We're going to take this 12 and we're going to multiply it by I. And we're going to need a step duration. So we're going to do step duration is equal to duration divided by steps. Now, this is all in integers, by the way. So we're also going to just do a floor on this, or just do an or 0 so that we break it up. Okay. And we want to make the volume drop off from the maximum, which is 1024, down to 0 as we're doing each step. So let's do that. So we have a start volume and an end volume. The start volume is going to be equal to, let's see. Our slope is equal to 1024 divided by the number of steps we have, right? So we want to do 1000 step start volume equals 1024 minus I times step I times 1024 divided by steps. I think that should be it. And then we want to do our end volume. Is going to be equal to I plus 1 times 1024 divided by steps. Right? So when this, if we had 12 steps, then this is going to be 11 will be the last one. So this would be 12 times 1024 divided by 12, which is going to be an end volume of 0. Yeah, that's what we want. All right, cool. So let's go ahead and take our start volume, put it right here, grab our end volume, put it right here. And now for the frequency, we are going to make this be we want to go between the low frequency and the high frequency, depending on if this is an even or an odd step. So we're going to say if I and 1 question mark high or low, and then do the same thing for the other. All right, okay. This all probably sounded like a bunch of nonsense. Let's go ahead and actually like call this now. And we want to do return buff at the end. All right, so we're gonna go into here. We're gonna do music play instructions, and we're gonna do call make sound. We're gonna pass in 2 things. So we're gonna do like, I don't know, 500 and 400. We'll do a duration of 1 second, and we'll set our steps equal to 10. And let's hear what we get. Oh, okay. I didn't mean to make that go smoothly.
You just made a stun sound effect.
Yeah, what did I mess up here?
The dizzy noise.
Oh, yeah.
It should be going like just high, low, high, low, high, low, high, low. It shouldn't be
Like player
transitioning
one
like that.
drank
So
questionable potion or something.
yeah, what did I mess up?
We're passing in the volume. Oh.
It sure seems like it should be working. Maybe I have misunderstood something. Okay, so what we're doing here is these are our 2 frequency arguments, this first one and second one, right? And I'm checking to see if I is even or odd. And to do that, this is just a fancy way of checking that. Taking an integer and then bitwise anding it with 1, which is just the rightmost bit. If that returns, if the thing on the left has the rightmost bit set, then that means it's an odd number. So if you if that and returns a number, it'll return 1. That means it is odd. If it doesn't, it's even. So it's just an explanation of that. So what this should be doing is when I is odd, it should be passing in the same high value for both of these. And when I is even, it should be passing in the same low value for both of these. Right?
Can you play that sound one more time? Because Wolfwolf says, I went through the painting when you played that. Mario 64, you just jumped in.
Antonio Arduino says, what's this? Yeah, we are just playing with sound stuff today. Wolfwolf says, I'm going to be messing with it so much. Yeah, it's a lot of fun. At least I like music stuff a lot. So, yeah, I don't know why it's... I wonder if this is just a byproduct of our implementation. Like, if I make this a much longer time, like 10 seconds, is it going to sound more... No, see, it's like the first one plays like you think, but then it's transitioning, which we don't want us to do.
This isn't something like we would have done to fix the issue where it was like clicking between sounds before. We didn't add like a smooth transition inherent to it, the simulator.
The frequency shouldn't be
It shouldn't be doing it. It shouldn't be doing that. But I'm trying. Like I'm thinking of it as like a byproduct of bug fix.
No, I mean I might have put in some smoothing, but I shouldn't have. So if that's the case, I should be able to do this steps times 2, and then do
like one short one and one long one or something like that.
Yeah. And then we just put in a random bumper at the end, which is going to switch it. So do I plus 1.
Wait, 12 times I plus 1. And then when you do I plus equals 2.
And then we're going to take the duration and change this to be 1 instead. And then we want to do I
plus equals 2.
Yeah. And then I is less than steps. No, wait.
I guess we can just do 2I and 2I plus 1. And then we don't have to change anything.
Yes, that is what we want to do. 12 times 2 times I, and then 12 times 2 times I plus 1. All right, that's what I wanted. What's up?
That's probably a bug fix we need to implement.
Yeah, maybe. So let's make this a shorter sound. Okay, that's what I was. This is what I was going for.
Yeah. I like it.
Okay, so that sounds like an arcade
Hello?
machine, right?
It's a phone call, right?
Oh yeah, I get phone call from that.
But I could see it also.
Oh, this is MKCD speaking.
That doesn't sound like an arcade to you guys?
I see it.
No.
I get phone first, but if I think about it, I can see where it's an arcade.
I don't know what sound I would associate with an arcade. I feel like the Bing sound that we have, or Bading or whatever the heck in that block is like what I would associate with arcade sounds.
I feel like Pac-Man is probably the arcade sound at this point in my mind.
I associate this sound as a part of a broader arcade soundscape that also involves, a roller coaster in the background, screaming and bells going off,
Maybe. I don't know. I could also just be projecting something, but okay. Wolf, as I says, the coin collect sound is distinctively retro arcade feeling IMO. You guys are all just saying that because of Mario. And which, fair enough. Wolf says, all right, what happens when you put 144 random numbers into the buffer? All right, you're going to make me do this. It's not going to sound good, but if you want me to do this real quick, I will. I think actually you'll probably get something that's just junk, but let's do it. So we're going to do
whatever sound this is should be used as the intro sound with the logo.
But they're random, so we can't control it then.
Oh. Even better, it changes every time.
All right, and now I'm going to make one change to this. So we're going to set random things to everything except the waveform, because the waveform has to have one of these values or it'll just be silent. So
just make an array of all those values and pick random.
Yes, that's exactly what I'm going to do.
Okay.
So we're going to go ahead and do for let I equal 0, I is less than buff.length, I plus plus, buff of I equals math.random times 1 byte, which is 0xff. And then we're going to say if okay, now which byte is the waveform? I think it might be the first byte. Yeah, the waveform is the first byte. So we're going to say if I mod 12 equals 0. Then we're going to say buff of I equals, and we're going to go ahead and put in our random values. Well, all of our acceptable values, which are 1, 2, 3, 4, 5, 11, 12, 13, 14, 15, 16, 17, 18. Dot. Oh, wait. Isn't there a pick
I think
random?
it's underscore pick random because we didn't want it to be
Oh, you're right.
exposed because it's not a real function.
Yeah. All right. I'm going to play this. Don't say I didn't warn you, okay? This is not going to be fun. Let me turn the volume down before we do this.
Yeah, I'm a little nervous about the volume.
All right.
It's like a TV
So we
tuning.
got a chainsaw, like a grinding saw.
It's like a radio tune. All right, so it's like fuzzy, right? Like in the screen, and then the fuzz slowly fades away, and to reveal the MKCD logo.
This kind of have like alien tractor beam vibes.
Yeah, I feel like this is like evil person in Doctor Who.
This is also just one part of the sound. Like, I feel like this is going to go on for 10 minutes because we put in random numbers for the duration of each step. So each step could be up to, I don't know. So I'm pretty sure what we're hearing right now is the tuned noise up to a ridiculous frequency.
Oh, it's still going.
It's going to go on for a long time.
Honestly, we should use some. Like, I really do get like arcade vibes with this. Like the old shooter, like like Galaga and other space shooter games. Like, I don't know, it's perfect.
Right. Epic Shrimp is accusing us of doing audio terrorism right now.
Maybe we should stop because this one is pretty bad.
All right.
Just blame Wolf Wolf, Epic Shrimp.
Upset every dog in the neighborhood.
Whoa. The rocket's taking off.
That's pretty good, though. Do you know how to make this sound, Richard?
Yeah, that's easy.
Okay. See, that would be the worst if we made the perfect sound, but it was hard for Richard to identify how to make it. And I don't know if that's feasible for your sound.
That's just literally one of these noise ones going from, a low frequency to a high one. Wolf Wolf says, I'm laughing so hard right now. Yeah, well, you asked for it. All right, I'm going to restart the simulator to kill whatever time bomb we
created
had
something beautiful today.
So what we really should do is, for Wolf Wolf, we should make it so it prints out all the values of the note on screen as each one plays. But, we're not going to do that right now. Oh, it is 2 already, too.
Yeah, we're out of time, unfortunately. So thanks. We didn't, get that much done today. See you, Ben. But
I don't know something to make it for him.
What I was planning to do was I wanted to do an echo effect, which I don't know. Do we have a meeting right now, or do we have like 5 minutes?
You can do a little bit more. I think. I don't have anything right now.
I don't think I have any meetings.
Okay, yeah, we're good. All right. So I want to do an echo effect real quick. So the way we're going to do this is we're going to take our sound and we're going to repeat it at lower and lower volumes. And then play that. And we're going to try and simulate an echoing effect.
Yeah, it'd be very interesting to look up. I wonder, what happens to a waveform with an echo? Is it just that the volume decreases, or is there changes to the pitch as well in an echo?
Well, so there are 2 typical ways that delays are implemented. At least back in the analog days. So the most common one was what's called a tape delay, which is so when you're talking about a tape player, whether it be a reel-to-reel player or a cassette deck or something like that, it has 2 heads. Okay, one of them is playing whatever goes under it. All right. And one of them is recording whatever it goes under it. Okay. So, well, actually, not recording, it's writing whatever it's recording to whatever is under it. Right. So, you have sound coming in, the record head, the write head is writing that onto the magnetic tape, and then it passes under the play head, and then the sound is played. Right. So the delay is created by the amount of space between those two heads, right? Because it takes time for the tape to travel from the write head to the play head. But those, in terms of frequency, are pretty similar. There is some saturation stuff that happens the louder that a sound gets with tape. But once you're kind of below that volume threshold, it tends to be pretty clear in how it's reproducing the sound that is coming in. All right. And the way you make an echo, by the way, so that's good for one delay, but the way you make it echo is you feed the output back into itself at a lower volume. So that's how you create the loop. And that's usually referred to as the feedback. So the other way that you would do this is more modern digital things. And those are even cleaner in how they reproduce the sound, right? So the old digital way of doing it, though people often still call these analog delays, is what's called a bucket brigade chip, which is the reason it's called that is because back in the day, like if you had a fire and you didn't have a fire truck, you would make what's called a bucket brigade, where you would have a ton of people standing in a line. They would fill a bucket with water and they would just pass it to the next person. They don't dump it, Thomas. They just pass the bucket.
It'd be way more fun to dump it, but less effective.
I was thinking the same thing, but it would be like by the third person you get like this much water.
Yeah.
I wish there was a better way to do this.
Yeah.
Man.
And so the reason that it's called a bucket brigade chip is because it works kind of similarly. It has a bunch of basically tiny buffers that it is writing the sound into and then passing it to the next one, passing it to the next one, passing it to the next one. And that case, the length of time that the delay happens is controlled by basically the number of stages that you have, right? And similarly, feedback works the same way. You just take the output, you put it back into the input, and that's how you end up with a thing. And now digital delays work more like you think. You have a buffer, you're just writing into the buffer, and you read back in. So those are pretty much perfect in terms of reconstruction of the sound, as long as it's above, like the Nyquist frequency or whatever. So anyway, that's how delays work. So delays typically were prized for accurately reproducing the sound over and over again, just at a lower volume. But a lot of delays also have the ability for you to, when you're doing that feedback loop, you can mess with that feedback loop, right? So you could put it through like a filter or something like that if you want to, filter out the high frequencies so that all the echoes you get are only the low frequencies and stuff like that. All right. Anyway, so to make an echo effect, we want to take our sound and we're going to play it over and over again multiple times, just at a lower volume each time. So we're going to go ahead and take our make sound function here, and we're going to pass in a volume parameter. And this is going to be a number between 0 and 1. And we're going to take this volume and we're going to multiply it times this volume. So that's why it needs to be between 0 and 1. All right. So let's go over here. We're going to pass in 1, and we should be getting the same thing we had before. All right. So if we want to make this echo, we're going to do this a bunch of times. So this play instructions thing takes in a win parameter, which is how many milliseconds in the future you want this to play. Actually, I can't remember if it is the total time or if it's the time in the future.
Does it say do we have content like?
Let's pass in 1,000, and this will make it clear pretty quick. Time in the future. All right. All right. So we're going to go ahead and make a parameter here. We're going to call this delay time. And we're going to set this equal to, 100 milliseconds. And we're going to go ahead and do repeats, which we're going to set to be 10. So we're going to do a loop here. We're going to do let I equals 0. I is less than repeats. Oh, whoops. I++. And we're just going to go ahead and call our music play instructions. But we are going to change this 1 to be 1 minus I divided by repeats. And we want this to be equal to I times delay time. Okay. Okay, see, here, let me turn the volume back up. Let's make the delay time a little bit longer so that we can tell what's going on. So our duration right now is half a second. Is that right? Yeah, 500. Let's make this be 300. Let's set our duration equal to 400 so we can actually hear a gap. Okay. So we probably want there to be some overlap because, to be honest, it's kind of hard to hear the effect, I feel like, if we have that. Or maybe we just want to reduce the number of repeats and... I don't know. Let's make it be 300. Yeah, actually, turn the repeats back up. Too much. Yeah, and then make this be... Let's do something lower. So we'll do 200, so there's overlap. All right, so that's how you would do an echo effect. Which I mentioned that one thing we might want to do is we would have like a little thing, and then we would make the last note like echo, 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 and then once the animation is done. So you do something like this. All right. Anyway, thanks for tuning in, everybody. We're over time, but it's always fun to do a Friday stream. If you want to see us do more nonsense where we don't accomplish anything, tune in next Friday for whatever we do then. Probably still working on this Lego thing. But on Monday, we'll be back to working on our isometric renderer. So if you don't remember that, we've been working on an isometric rendering engine, which I'll show off real quick. There we go. Move this up, rotate around. Woo, look at that. Pretty cool. So we'll be working on that on Monday. And a reminder, we have a mini game jam going on right now on the forum. So check it out. The theme is tiny games. So it can be games about tiny sprites, games with a tiny screen, tiny in terms of length, whatever you want it to be. Just make a game and we'll play them all at the end of the month. It's always a lot of fun.
Yeah.
And anyway, I'm Richard. I'm Richard on the MakeCode forum.
I'm Joey at JWonder on the MakeCode forum.
I'm Sarah at Sarah on the MakeCode forum.
And I'm Thomas at Sparks on the MakeCode forum.
And yeah, we'll see you on Monday. Bye, everybody.